When you say string copy, do you mean strcpy? Okay. And it takes 3 parameters. What are the parameters?
So it's the destination first,
Yeah.
followed by which string you're taking from, and then the index for the destination to start at, or is it the index to start at from the source?
Number to copy. Number of bytes to copy. I think. If I tell you something wrong, and you look it up, I could be wrong. But now that you say that, that's a different function. That's a different function. Nope. It's only 2 parameters. Only 2 parameters. String copy, strcpy only takes 2 parameters. Destination of the source. Make sure the order of those is correct. Yes, that is the correct order. So while we're on the topic, what type are these parameters? So character array could be true, a string type could be true. What are both a character array and a string type? They're character pointers, right? So they're both character pointers. Question? 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 Question?
If you have like some kind of array within a struct, to access it directly and change it, you use string copy.
You have an array within a struct, so I suppose you have here ARY.
So then to access that array directly, I would use string copy.
When you say directly, what do you mean by the word
I mean,
directly?
like, as opposed to if you had 2 variables within the struct and then you initialize the struct and then you declare the variables at the same time. Because I was working with it earlier and I couldn't, like something like that. But
There's no magic here. These are just subfields of this structure. Declare a struct S. Call it my S. You allocate. This isn't declaring anything. This is declaring a type. This is actually declaring memory. The only way to access other or ARY is by first using the name myS. Right? So for our instance, suppose you wanted to copy one into the other. You have to say mys dot other if you want that to be the destination. Mys dot ARY would be the source.
I mean, like if you wanted to input like a name, like if I were supposed to put like mys.other, comma Bob into that character array, one of them.
You mean right here?
Yeah.
Suppose you wanted to put,
As opposed to just mys.other equals Bob. Because would the other way work? The mys.other equals Bob?
I don't know. I know it would work it for initialization. I don't know if it would work in syntax.
Because I was trying it earlier and it that way didn't work. Well, the only way I could do it was through string copies.
I don't think this would work. This one only works at initialization declaration, I think.
Yeah, that's why I was on that.
So I don't think that would work. I'd be surprised if it would work. We would have to use this.
Okay.
They just give you some shortcuts for initialization purposes that, in retrospect, may be unfortunate. Just to give you that shortcut for initialization purposes, it seems reasonable to give you this, but there's no C syntactic structure that makes this make sense, complete sense, in the structure of the language. Other languages it will, later on, when you get to C# and Java and what have you. Okay? Question?
All good.
Second row, question. Question?
Yeah, so can you only pass a structure by reference to a function?
So the short answer is no. I think there's more to your question than that, though. You can pass it by value or you can pass it by reference.
Okay, how could you pass a structure by value to a function?
Suppose you have this structure over here named MyS. This is your function. This makes it by value because it's not a pointer, right? You could then say, suppose you have that declared, you could then just say, that's passed by value though.
Oh.
So in other words, if you change this thing inside of here, it has no effect outside of the function. That's the difference between passed by value and passed by reference.
Oh, good. Thank you.
Next. Question. Wake him up. Question. 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 Okay, let's hope this means studying occurred. Question on the back row. First person. Question on the next.
Oh, okay. Now I don't think I have a question.
Question, 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 question. Side row on my left. Question, question, question. Question, side row on my right. Question, question.
Can you show an example of how you...
I do not show examples of. I mean, of course, I'm answering a question. I may construct an example, but I have to ask a specific question. Hence the term specific questions. Example of would have been last week.
A function that takes a pointer.
I can show an example of a function that takes a pointer. And you can ask a specific question. But you can think about it, we'll come back. Question, question, question. Front row again. Question.
When you pass by reference, when you pass the struct by reference, that's by value.
This is by value,
Right,
yes.
so when you pass the struct by reference, that's when you use the arrow.
When you pass a struct by reference, this ends up being a pointer, right? And then to access the point, so the parameter name in this case is param_s. So to access the variable, you would use the arrow operation, param_s, other verses. You may have accidentally answered his question. We'll see if he has a more specific question when we get back to him. Question? Right, is it about this?
Yeah, I forgot to add the ampersand in the Maya, in the function call. I think it needs an ampersand, right?
Where?
You know, like func,
Func minus under
below the function definition,
the call.
the function call. Yeah, and then check my.
Oh, after I changed it.
Yeah.
After I changed it, you were correct. You would need an ampersand. Thank you. That's correct. Where was I? Sorry. Question. Question.
What was the other way of dereferencing it? Instead of using the pointer, instead of using the arrow?
You mean the painful way?
Yeah.
Take param s, dereference it, right? Use parentheses just to make sure you're not confusing order of operations. And then period other the one, but this is the part you're talking about. You dereference it, and then you use the period operator, the dot operator. Okay. Question?
If it's a struct within a struct, the struct that's in the struct, the sub-element struct within the structure, if it's a pointer struct, then is that the only situation where you would use double arrow operators when you're calling within the sub-element structs?
That's the only case we have talked about, yes. Well, actually, you would only do that if the thing inside required a pointer operator. If the thing you were referencing inside was a pointer. In other words, the arrow operator only applies when the left side is a pointer. If it is not a pointer, you do not use the arrow operator. That would be the correct way to say that. Question? Second one, question.
So for that one, the struct S, if we choose the first one, the char other, if we use the pointer, the char asterisk other, then we can use the at the bottom my s dot other equal off.
I think you lost me there. There's no pointer involved over there on that side of the board.
I know if we change the other, because this is array, which we change that one. Because for this situation, we can only use this string copy, right?
So in other words, if you string copy takes 2 pointers, okay? But if you're saying suppose you did this and then use something like malloc to allocate that, and you changed the question. Well, okay, let's go with this.
Yeah, because they are the same, the data type, the chart.
It would still be this is still a character pointer, right?
Yeah.
This is still a character pointer. It all works as long as you had allocated this somewhere. It's still a character pointer you're passing to string copy. In both cases, right? An array without a subscript is by definition a pointer of whatever type the array is. In this case, a character array, right? If you just use the array name, it's a character pointer. Similarly, if you make an explicit character pointer, it's still a character pointer. Right? That's why arrays are done like that. Because that's what they really are. So think about that, and when we come back around, you may have another question. Question? 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 Third row, question, 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 question. Question, yes, sir. Oh.
If we have pointer other on the after the chart on top, and would we have to change it on the bottom after my s would be my s dot pointer other?
This one?
Yeah.
No, that's what she was asking. It's
No.
still a character pointer, no
If
matter
we
what.
put two pointers, so char, pointer, other, on the top, so would we have to put?
Char pointer other,
we
other,
put
you know,
two
char,
pointers.
okay, hang on. Forgot what I put there. Other is just by itself without a subscript, used later on without a subscript, is a pointer by definition. This is a pointer because you defined it explicitly to be a pointer. They're both pointers when you use them without a subscript. If you use either one with a subscript, it is a character variable, not a pointer. Because you can use this. If you declare it like this, you can still say other sub 0, and it's fine. It's just that index of that array, which a pointer is an array is a pointer. Excuse me. An array is a pointer. A pointer is not necessarily an array.
What would happen if we put two pointers, and then would we have to put like so pointer other on top, or two asterisks?
Okay, we haven't talked about anything like that, so it's not a relevant question. That is relevant in some other cases that we may or may not get to, but not relevant for anything we've talked about. I was going, I forgot what direction I was going. This one, so, do you have a relevant?
Yeah, relevant to that, how does, like, the computer know how much memory to allocate when you do string copies? Just whatever's inputted, that's how much memory is allocated at that pointer going forward?
It doesn't allocate, string copy does not allocate memory.
Well, it puts Bob into the memory location for wherever.
Right, the compiler, okay, when you see quote Bob quote like this, the compiler generated a constant read-only character array named Bob with a null terminating 0, \0, which is null termination, that you can access behind your back. That's all it did.
Okay.
No magic. Got this?
No, not for that.
I'll come back.
Okay.
I was going this way. Okay. Next. Question, going down the fourth row. Question. Back row. Question. No? Question. Left side row. Question. Right side row. Question. Okay.
So, the character array would, let's say 30, that can take up to 30 characters.
Well, yes. it is
Yes,
30 characters.
so padding of that would be 2 bytes, if I'm correct.
You mean if you put it in a struct?
Oh, yeah.
Yes.
So if there's 33, would the number of padding be 3?
Yep. Assuming it's a 4-byte machine, 4-byte architecture, yes. It rounds it up to the nearest number of bytes for the architecture, which is going to be 4 for 32-bit machines, it's going to be 8 for 64-bit machines. Okay? Question. Last round. Question.
For the, for the padding he was mentioning earlier, it takes the padding of the largest data type
Nope.
based on that, or is it just?
It pads it up to the word size of the machine with the operating system, which will typically be 32 bits or 64 bits. We haven't yet moved to 128-bit. Well, actually, they have them, but they're not in common use. 128-bit machines are not in common use. For our purposes, don't worry. I have to, if I ask you a question like that, I have to tell you what the word size of the machine is. There's no other way to know unless you're explicit. Almost all computers these days are 64-bit machines, but not all. Some are not. There are some specialized computers that are 32-bit. It's cheap. Question. Second row. Question. 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 Fourth row. Question. Going down the fourth row. Anybody on the fourth row with a question? Anyone on the back row with a question? Side row, left side row questions. Right side row questions. Okay, 5 minutes. Don't be longer, because I'm going to close the door and lock it. 5 minutes if you need to go, because you have 50 minutes to take this exam. 5-0. So. Okay, subject is files. Okay, where did the topic files come from? It's important to know where things come from. We talked about earlier on where the topic of computers came from. Computers came from people who were doing computations. This was back in World War II, before there were actual computers like you have there, the big computers that filled up rooms. Computers were people who did computations, right? In World War II, there were a lot of them that were mostly women, actually,
He shut it down.
historically speaking, because that's just how it was. Because the women were very useful and were very good at doing those computations that the scientists needed. So, files. The topic is files. Where do you think the name files comes from? Some of the things like this that would appear in file cabinets. Okay? This is where, when they first started computers, they had to come up with a name for something that holds something. Something that holds something is called a file. Because they had big file cabinets full of file folders. That's where the name file came from. So, the point being, that's what you think of a file as. Something that holds something. Okay? A file holds something. Now what it holds is up to the programmer. You'll have definitions of things like that. So that's where the concept of files comes from when they first started computers. Okay? So think of it as having something like this that you can get things out of. Now we'll talk about different ways of getting things out of that file. But before we get too far down that path, let's review a little bit. When you use the fopen method, what type is returned from fopen? What type is returned from the fopen statement? Fopen method called?
Was it a file pointer?
It is a file pointer. All capitals, F-I-L-E. Pointer, let's just suppose you call it F. You can call it, it's a variable, give it whatever name you want to. But its type is a file pointer. Now remember what we talked about last week? We talked about fopen, fprintf, fscanf, and fclose. You know what's embarrassing? When you go and visit and you realize your 4-year-old granddaughter has better handwriting than you do. That's not embarrassing, that's a hopeful thing. Okay, these are the things we talked about. So let's just review these real quick before we go. So the first thing we discovered in review is that fopen returns a file pointer. What parameter do you give to fopen? It is a character array. More specifically, it's a character pointer. That is the file name. What's the second parameter? It's called mode.
Mode.
And what kind of parameter is it? Says it can take something like this. Should it be a character?
String.
It has to be a string. And remember, you were all given the handy assignment to go look up all those modes. What are some of the important modes? There's a lot of them, so let's talk about the more commonly used ones. Pick one. All right.
Reading.
Just that was so easy, pick another one.
W for writing.
Oh boy, not original at all, but that is the next logical one. Next person.
A for a pen.
Oh, hey, look at that. After working with my 4-year-old and 7-year-old granddaughters, you can imagine how much patience I'm going to have for you guys tonight. You know, when they can do things very well. Not this stuff, right? But actually, they can do some of this stuff, sadly. I read the book that says, Quantum Mechanics for Babies. I said, I know you're not a baby, Naomi, but we're going to read it anyway. So she was explaining it to me before we got to the end of the book. How quantum mechanics works. In a very junior level. Okay. What does the pen mean?
To attach something at the end of the file.
Yes. It starts adding at the end of the file. That's exactly what a pen means. Okay, and there are others, right? There are others that are different. There are others that are variants of these. Things that have like R plus and things like that. Okay, that is fopen. Fprintf. Next person. What is fprintf like? What is it exactly like except for one small difference?
It either prints to the file or prints from the file.
Pretend like it didn't have the F in front of it. It's printf. F is to the file. Print is always output. It's always to it. Scan and or read, but for now scan is the input. Print is output. So what's the difference between printf and fprintf? The only difference. Next person. The only difference between printf and fprintf. Well, let's do it this way. Let's just write fprintf. What's the first parameter to fprintf? It's going to be a file pointer. Let's just give it a name F. We'll let her try again. What's the second parameter to fprintf? No, we've already opened the file, right? The file pointer is what refers to the file we've already opened. What's the first parameter to printf? Just forget the F. What's the first parameter to printf? This is all going to become very logical in about 20 seconds. What is the first parameter to printf? You're going to say printf and you want to print an integer. What are you going to put? And then you want to print that out. What do you put? Okay, placeholder. What does the placeholder go inside? The quote. And because it's an integer, what placeholder do we want to use? That's how we would output I. Fprintf is exactly like printf, except it has one additional parameter at the beginning, which is the file pointer to where you're going to do the output. Okay, so if I had an int I up here, I would just do the same thing. And whatever file I opened, it would do exactly the same thing as printf. Fscanf is exactly the same thing. It is exactly like scanf, except you have a file that you're going to write it to. Now, most often that file is going to be a disk file. But now we get to the subject of stdin, stdout, and stderr. What type do you think stdin is? stdin is when you type on the keyboard. So what type do you think the variable stdin is going to be?
What type, as in one of the 3 types?
Well, you have all sorts of types. You don't have all sorts, you have a number of types. You have a file pointer, you have an integer, you have a character, you have a double, you have a long, you have a structure. So stdin. Just take a guess. What's going to be its type? It's going to be a file pointer. stdin, stdout, and stderr are all file pointers. stdin is the default file pointer that you get with the standard I/O library for the keyboard. stdout is the standard file pointer that you get that outputs to the screen. stderr is where errors happen to be written by the system, which also happens to be, well, it's not true. It can be the screen.
Isn't the concept of a file a bit different than something that has active input or output, like a keyboard? So, like, what's the difference between an actual file, in this case, and standard in?
I'm glad you asked that. A file is really a stream of data. Now that definition doesn't say where the stream is coming from. It doesn't say where it's going to. A file is a stream of data. It can be coming from disk. It can be coming from a keyboard. It can be coming over an Ethernet connection. It can be coming from a carrier pigeon. I'm not kidding. Conceptually, it's the same thing. It's a stream of data. Same thing for output, right? It's a stream of data that may be going over the network wire, Ethernet cable, maybe going over the Wi-Fi, over the airwaves. It may be going to the screen. It may be going to a disk file. This is what a file really is. It's a stream of data. So when you look these things up in some of the better text, it'll refer to things called a file stream. Actually, it'll refer to streams in general. When you get into more advanced languages, you're going to see that they refer to memory streams, to text streams, which are subcategories of other kind of streams. Streams are flowing data. Like, think of a stream as flowing water, right? We just had some rain. We actually got to see a little bit of flowing water. Very little bit, but a little bit of flowing water. That's what a stream is, okay? In the concept of computers, a stream is flowing data. You have a file stream, which means it's going to flow to and from a file. Not in this class, but in other classes, you'll have memory streams, which is just streams to and from memory. You'll have text streams, which is a data stream of a particular type, i.e. it is text, it is not binary data. Text meaning characters that are readable, ASCII characters. Whatever code format you're using, characters. But for our purposes, you need to think of a file as a stream of data. A given file is going to have a source or a destination or both. Now, one of the things you can do in the modes, you can both read and write. There's another mode that says read and write. I can't remember if it's RW or whatever it is. But you're going to need to know because you have to write programs. Well, you know what? I can't swear to that. I don't know that you have to write programs that go both ways. I can't remember. But this is what a file is. You have to get this concept down of what a file is to understand all the rest of this. Just like pointers, right? You had to understand what a pointer was, to understand how to use them and what they mean, and how data flows into and out of pointers, which are the things pointers point at, actually. Same thing with files. So, standard in, standard out, standard error. They are provided in the standard I/O library. And by default, they are pointed to the keyboard for standard in, the screen for standard out, and standard error is a special case. Now, if you happen to look at the online C compiler you're supposed to be verifying all your programs against, if you look down at the bottom where the output comes out, you will see things like standard in, standard out, and standard error. You'll see those very names because that is what it is intercepting and pulling from. So, fprintf, so printf is actually defined to be a method that simply calls, we'll get to the dot 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 later, that's a variable parameter specification. But printf is simply fprintf, where it passes standard out and whatever else you pass in. That is literally how fprintf works, right? That's literally how printf works. Printf simply doesn't encapsulate, it calls fprintf, passing standard out as the first parameter. Fscanf does exactly the same thing, except it calls scanf is the same thing. It calls fscanf, passing standard in as the first parameter, because it's just a file pointer.
Is that format that's it's a, like stdout format?
I just gave it a name up here, format.
Oh, okay.
Whatever
I can see
parameter
it,
name here is, it passes to here. It doesn't
Yeah.
even look at it.
I can see, but I wasn't clear that much.
What is stderr again?
stderr is a standard place where errors are written to. So for instance, suppose your program's running along and you have a divide by zero, or you have an integer overflow, or you have a invalid index. It would write whatever operating system message that occurs, just standard error. Now in a lot of cases, standard error is simply pointed to the same place as standard out.
Okay.
When you run a program, in fact it is. Like when you run a program through a command prompt or whatever. But in the C online compiler, there's a separate field that you can click on for standard error. And you can see the errors over there. Now if you look at that online compiler, it has standard in. And if you look at standard in, you can say, well, let me see what it says exactly. Oh, it doesn't say standard in, it says input. They're being inconsistent. They should use standard in, because at the bottom of where you put your program, it says input, standard out, and standard error.
And if you wanted to print something in standard error, you just use fprintf?
You could, yeah. If you click on the input tab, you have input, it should say standard input. Well, I know why it doesn't, because there's a subcategory under input. It says input, standard out, standard error. When you click on the input, you have two choices. One is interactive console and the other is text. Now when I grade your programs, I copy your program, I stick it in the compiler, and then I click on input and I say text, and I copy the text that I'm using to input to your program. I don't type it every time, it may surprise you. Copy it and this thing automatically gives it to the program as it runs. Makes my life simpler. Perhaps it will make your life simpler now that you know how to do that trick. But that's all that thing is doing. It is taking standard in, standard out, and standard error. And you can redirect where they go to. By default, standard in is keyboard, standard out is the monitor, standard error is just intercepted as you want to. If you do not specifically intercept it, I think standard error will always go to the monitor. But you can intercept them and point them at different places, because they're just file pointer variables. You can change them to what you want them to point at. You can change them to, like, when it says text, it takes standard in and has pointed it at a text file. It actually doesn't. It points it at a stream that intercepts and passes it, but you don't need to worry about the details of that.
The standard error also point at a text file?
You can make it point to a text file, yes. If you wanted to take any error output and write it to a text file, you certainly could.
An error output is something wrong, sorry, something wrong written in the code, right? Or no?
It's something that the operating system detects as your program runs. Like an invalid index, like out of bounds, like divide by zero. So if you wanted to redirect standard error, what you would do is you would do an fopen to whatever location you wanted to write it to. Suppose it's a disk file. And you would get a file pointer. And then you would simply say stderr is equal to that file pointer. At that point, you have redirected stderr to wherever you have pointed that file at. In your implicit homework, which I failed to write up there, try it.
If I'm redirecting it to the file pointer, what's the purpose of the encode?
Encode?
Yeah.
What do you mean
Because
encode?
you said stderr equals to file pointer. What does that do?
Let's back up and just take a general case. If I do that, I have now taken this array and assigned a pointer to it. So I can actually use two different names to access the same thing. So if I say file pointer f is equal to fopen, and I then say stderr is equal to f, stderr now points to whatever fopen created. It's just like that,
So it's like
except
a
with files.
substitution.
Yeah. Not substitution, it's...
Well, yeah, sorry,
it's an
it's the
addition.
wrong word. I mean, since that
Yeah.
was the fopen and its context, yeah, stderr equals to f, so stderr equal also to fopen in its context.
In other words, stderr pointed to something else, let's say the monitor, before this statement. After this statement, it now points at whatever f is open to. You've updated stderr to do something different. Just like I've updated parray to point to this instead of whatever it was pointing to before, which would
Does
be
it also mean that stderr is equal to file pointer?
stderr is a file pointer. File pointer is a type. Just like int is a type. Just like float is a type. Just like if you declare a struct, that is a type.
So file pointer is a type, not file by itself.
Actually, yes. You don't need to worry about the details underneath the hood. File pointer is the type that is relevant. Okay, fprintf and fscanf. They are simply used to do the same thing printf and scanf do, except to a specific and from a specific file, whatever file you give it. Fclose is obvious. Fclose is the reverse of fopen. It just closes the file you opened with fopen. Question? Is there any difference between fprintf and fscanf? Let me ask you a question. Is there any difference between printf and scanf? Okay, it's the same difference then. One's for input, one's for output. Same thing for fscanf and fprintf. One's for input, one's for output. Now I want to describe a database file system, a pretty trivial one, right, so that you can understand what files are used for. Remember, there is no magic. You need to say this to yourself all the time. There is no magic. Not in a car, not in your cell phone, not in your computer. When you talk to Alexa or Google or whatever Facebook's is called, there's no magic. Okay? Everything works. If you're going to go into computers, you need to start understanding how things work deeply. Not just accept the magic. It's okay to say, I don't need to know the details of how that thing that seems like magic to most people works. I don't necessarily need to know the details. You need to know it's not magic. And that something is working and that some engineer somewhere knows exactly how it works. When you start approaching things with that mindset, you will discover your world opening up. You will discover you have all sorts of questions about things. Hardly a day goes by when something that I have taken for granted for all of my life, or part of my life, I stop and think, well, I wonder how that works. And I start thinking about how it would work, how somebody could engineer it to work, right? When you start approaching things from that viewpoint, everything like this is going to become much easier to. Tiny percentage of the human race that does that or can do that, right? And it's a sliding scale. I told you about my poor daughter riding the ski lift, asking me how the ice machine works, how the snowmaker works. Even today, that poor child who is now 36 can describe PVT equations. Not in the details of PVT like me, a physicist, can, but she says it has something to do with pressure and temperature and volume, and she knows that from when she was 6 years old, right? Because I inculcated in her the mindset to always question how things work. Database file system. Let's talk about a trivial database. We have a class, we have students. You guys all have first names, last names, and student ID numbers. Okay. So if we're going to make a database of you guys, that's exactly what we'd do. In the program, it would look like this. And we'll just say you have one name to make things simpler. And we'll say your name is limited to 30 characters. And we're going to say you have an ID number that's an integer. It's not a float or anything like that. But I think that's actually true. That describes you, or some small piece of you, your name and your ID number. Now we want to have a database with all those in it, for all of you. So, we're going to write that. So as some astute person asked earlier, this would pad 2 additional bytes to get 32 bytes. 32 bytes. So we just add 2 bytes of blank space. So you would end up with a record on disk that ended up looking like this. Name that goes from 0 to 29. You would have 2 bytes of wasted padding. Then you would have ID that would go from 32 to 35. And that would be your entire record. So this is how the record gets laid out. That's how that struct record would get laid out. Sure.
So, where's the information at the beginning of the struct that says this is? Where is it stored that it says it has to be structured like that? I guess.
There is none. Or the compiler knows it.
Oh, okay. So it's never stored at the actual memory address that it needs to have, for example, a char name of 30 as well as the int ID, for example.
You're talking about, no, there's not. You're talking about metadata that the compiler keeps as he compiles your program.
Okay.
So that when he sees some structure variable s dot name, he knows where it must be in the whole student memory structure. And more importantly, when he writes it out, he knows where it has to go. He knows the order in which they have to go. The order is whatever you say the order is. It's up to you. Back in the day, there were people who really cared about orders, so they could save those 2 bytes somehow, if they could. Maybe they could, maybe they couldn't. Today, we don't worry about it. We don't care about 2 bytes. We might start to care about 2 million bytes, but we're not going to care about 2 bytes, because disk is cheap.
You said that ID is going to be in between 32 and 35 characters. Shouldn't we say int ID equals to 3?
No, I've just declared a structure. There's no variable there. This is what the structure would look like. I haven't declared any variable.
It's because it went past 30. And you did say that there's going to be 2 like white space, that's why there's 30 and 31 between the name and the ID. But the ID itself
Starts at byte 32.
sorry,
Starts at byte 32. That's all this means.
that's what the compiler already knows?
Yeah.
Oh, okay. So we shouldn't like declare and say set ID equals to 3. If the ID number is 3 numbers.
That's not what we're talking about here at all. We're talking about the structure of data, the structure of how something's going to look. And you have to separate very clearly type and variable. Type doesn't represent any memory. Okay? Type is simply something that can represent memory when someone declares a variable. You have to know the difference between type and variable.
Why isn't it 36 and why is it 35?
I was just gonna ask that.
32, 33, 34, 35. That's why. I mean, there's no way for me to explain that better than that. It's just like if you count the days in a week and you start at 0, what's the last day going to be? What number? 6, even though it's 7 days in a week.
Would the padding change at all if you initialize int first? I mean,
You declared it first?
Declared it first.
No.
No?
But suppose you declared a second one after it. But don't get hung up in all these details. Because the point is this. The point is this structure ends up having a memory stream set like this. Okay, this is how it gets laid out in memory. And more importantly, when you write it to a file, it gets laid out in the file the same way. Assuming you don't do anything odd, which most people don't. Because it makes it simple to write it out and to read it in. So when you have your database, you're going to have a record of these things. And let's suppose there's 50 students, right? You're going to have 50 records, one per student. And even though it's going to appear like one record, a second record, a third record, a fourth record, they're actually streamed together in a long stream on disk. That's just how things go. That's just how bytes are written.
In a string, you mean like that?
It'll be this structure.
Yeah.
This is how the structure will actually look.
So they would be in one whole line, all 50 records, not like under each other.
As far as the file is concerned, yes. The first record starts with byte 0. The second record is going to start with byte 36, and so on.
It would change though if it was
Don't worry about it.
chart.
Don't worry about all the off cases, okay? Just worry about the cases we're talking about. So that's how you write the database. You write a bunch of records. Okay? You write that in one file. Now, because we want to have intelligent access to it, right, we write a second file that's an index file. So what we actually end up with are two files. One file, and we're going to write it linearly like this. It has the name and the ID in it. And they are just in any order. And then we're going to have an index file. And let's suppose we use the index file. And the index file is simply going to contain ID. So the index file is going to contain two things. The ID and the record number. So the ID is going to be your student ID. And they're going to be maintained in this file in sequential order. I'm just making up ID numbers. Let's just suppose these are your ID numbers. They're going to be maintained in sequential order so that they can be searched very quickly. Doing something called a binary search, which you'll learn about in data structures class. But it means you cut, because these are in order, it means you cut the amount you have to search in half each time. Because these are in order, let's suppose I'm looking for 400. I go to the middle. I say this is 256. 400 is greater than that. So I've eliminated everything above it. So now I only have the half below it. That's how a binary search works. And it allows you to get to something very quickly. Log base 2 of n. So suppose you have 1,000 records. Log base 2 of 1,000. Anybody know what it is? It's 10. 2 to the 10th power is about 1,000. It's actually 1028. That's the power of binary, doing things in a binary search way. Instead of searching 1,000 entries, you can find it in 10 accesses. So that's why it's maintained in the right order sequentially. And then you have a record number. So suppose the ID here got written as 256, 573, and 278. This guy would have a record number of 0. This guy would have, see, this is 0, 1, 2. Right? This guy would have a record number of 2. 573 would have a record number of 3. So after you do your binary search, you can go straight to the record. And this doesn't have to be kept in order because it would be very painful to reorder it all the time. Forget 50 students. Think about 10,000 students. You don't want to have to reorder this every time. But reordering this, which is much smaller, isn't too painful. And all of this is kept in file systems.
Would we be able to reorder it using code? Like
Yes. Of course, everything you do has to be done in code.
the whole 10,000?
No, you don't reorder the whole 10,000. You just write them on and you put a reference to it over here.
Yeah.
When you think about what a pointer is, this is really like a pointer.
I was just wondering, is there any reason 573 is different index and record number, or the 1 and the 3?
Sorry. It was a typo. It was a scribble though. This is how databases work in the simplest sense. Someone should have covered this in a course before you ever got here about how computers work. But sadly they don't. If they had done that, you see, you might have made a decision differently about whether you should be here or not. Some of you would, some of you wouldn't. But this is how a database works. Each of these would be a file. And this is why you have files, to keep track of lots and lots of data. Anybody ever hear the term big data? That's a term they use, where we are now processing big data. And from big data, you can get all sorts of statistics. Your search engines can become more meaningful. Sadly, we are all part of big data, right? They say, okay, people in Southern California are much more likely to buy this, whereas people in the Southern United States are much more likely to buy this, right? We are all part of that big data. Some of it is statistical. Some of it is actually targeted to you. Anybody ever done a search on Amazon for product X and didn't buy it? And then for the next 3 weeks, you see ads for things like product X.
That's
Right?
the algorithm.
Hmm?
Isn't that like part of the algorithm?
It's exactly part of the algorithm. They said, this guy looked for product X.
Yeah.
So we're going to tell all these people that, you know, sell products like product X, that this guy was looking for product X. So they target ads to you. Has its pluses and minuses, right? We're not here to say if that's good or bad. That's for the people in Congress, frightening as that might seem. Right? But nevertheless, that's how it works. That's what big data is. Keeping track of you on a personal level is little data, but keeping track of us on an aggregate trend data is what big data is, right? Has all sorts of positive aspects too. They can do drugs with big data, create new drugs with different proteins and different foldings. Yes, sir. Last question.
Sorry. Is there a way for a person to erase the big data? You know, like
Not relevant to this. Not relevant to this.
Oh.
Call Google. Okay? The point is, you have databases. Databases are made up of files. The files are made up of data. Some of the data is ordered in a specific way. Some of it is not. Okay? But that which is not is referred to from the ordered data. To make all of this stuff work, you have to be able to write disk files. The point is, this is not just theory, it's not just abstract, it's real. You have to be able to write disk files. Now, the people who write databases like Oracle and Microsoft and all that stuff, they encapsulate all this, but you have to understand as a programmer what it means. Because you're going to have performance questions. If you write a database table and you do not give it an index, the performance of your program is going to be terrible. That's why you have to understand how this stuff works. Not necessarily down to the bits and bolts of it, but you have to understand how an index works to an unindexed table. That you'll find out about later. But before you worry about that, you have to know that they are disk files that are written on a disk. Be it a hard disk spinning around, or be it a solid state disk, which is what most of us, almost all of us have now, are solid state disks. They don't spin anymore, and they're much faster. But they also have a much higher error rate because of the nature of solid state disk reads and writes. But backing up, this is what you have to understand. The reason you have files, this is the biggest reason you have files. This is where big data is kept in databases. Where everything is kept is in a database of some sort. When you're driving your car, your Tesla, if you one day have a Tesla or a Chevy Bolt or whatever you have, right? They have computers that have stuff in a database that makes decisions to help you drive the car. So that's what it all comes from. And all of the databases are kept in files. Then they're kept in multiple files, but they're kept in files. That's why you have to understand how files work. Fopen is for opening the file. We're going to get to more complex stuff next week. But for now, fopen is for opening a file. fprintf is just doing printf like you've been doing all semester, except to a specific file. Scanf is reading data from a file, just like you've been doing scanf all semester, except from a specific file. And fclose obviously just closes the file that you opened with fopen.
How do you go backwards and forwards? So if you've read 1 out of 4 characters or strings, how do you go and read the first one again or something after you've read it?
We will get to that next week. The short answer is a method called fseek, S-E-E-K.
Okay.
But we'll get to that next week. fseek says, where am I going to read from next? We'll talk about that next week. Either next week or the week after. Well, we will talk about it.
It's not like in a good couple people with tents just going here. It's like legit. Yeah. Okay. That's good. Yeah, I think so much about it. Yeah. We could even solve another one too, something like that. This can be a bit.
All right, let's get started in the last 3 topics for the night. Don't forget your implicit homework. If you guys aren't writing programs just for the enjoyment of writing programs, don't try to be programmers because you will not succeed. If you don't find this enjoyable and aren't already writing programs, just to see what happens. Okay? All right, let's talk about 3 more methods in the standard I/O library. fgets stands for file, get, string. That's what fgets stands for. File, get, string. Now in these methods, they put the file parameter, the file pointer parameter, as the last parameter, as opposed to the first as we did in the others. I don't really know why, I just know that they did. So, for fgets, it means you are reading a string from a file. It takes 3 parameters. It takes a string parameter, which as we all know is simply a character pointer that you have hopefully pointed to a character array. The second parameter is the max number of characters, including the null that it's going to put at the end of the string. We're going to look at the conditions in a moment. And of course, the third parameter is simply the file pointer, okay, that you have already fopened and all that. So, the way fgets works, it starts reading data from the file you have specified via the file pointer until one of the three things happens. Max minus 1 bytes have been read. It is max minus 1 to allow space to put the null character at the end of the string. Because remember, you're constructing a string here, and all strings end by convention with a null, \0. So that's why it only reads max minus 1, because it has to have room to put the null character at the end of the string. So it reads until max minus 1 bytes have been read, or the new line character is encountered in the file. New line character is \n, remember. Or you reach the end of the file. It'll read until one of those three conditions are met. Now the typical condition you want it to meet, because this is text file I/O really, is you want it to go until it reaches the new line character. Because in other words, you want to read the whole line out of the file, however long that line is. But you also have to put limits on things. Suppose somebody wrote a file without new line characters. Bad thing. But suppose they did, it happens. Okay? You need to protect yourself because you've allocated only so much space in the array this is pointing to. You cannot overflow that. So that's why you have to tell it what the max to read is. And you read it from the file pointer until the new line is reached or the end of file is reached. Of course, the end of file is reached, there's no more data.
So if you initialize a char array as 30, is it 31 that you would put here?
No, you'd want to put 30.
Okay, so that would be assuming that the new line character or the null character would be part of the 30 then?
Right. Because if you've allocated 30, you don't want to tell it, go ahead and write 31, because you're stomping on somebody else's data. Maybe your own data, but you're still stomping on something. And in fact, suppose you allocate the array to be 30, and you give it a max of 30, in fact, it'll only read a maximum of 29 because it will put the \0 character there, the null character there. So that you have a valid string by convention in wherever that pointer is pointing to. That's how fgets works. Fgets is very useful for just reading text files, line by line. That's what it's for. It's effectively saying, read the next line in the file. That's what you're effectively doing. Because it stops at the new line character. Or your max, if you made your max too small. Or if the file is not what you were expecting. Or if you reach the end of file. Now keep track of this designation, capital E, capital O, capital F, EOF, which stands for end of file, but that has a particular value. You don't need to worry about the value. You simply need to know that the identifier EOF is part of the standard I/O library and you can use it. You don't need to use it in this context, right? We'll get to it in other contexts. It returns a character pointer. The character pointer it returns is simply the character pointer you sent in. When you get deeper into programming, you'll understand why that ends up being a bit of a convenience. But for these purposes, it won't be. Just know that's what it returns. Now let's move to the corresponding thing, fputs, which is file, put, string. This is reading data. This is going to be writing data. And it's a little bit simpler. It takes a character string that has the convention of terminated by a null, as all strings by convention are in C. into C++. And it's simply going to take that and write it to the file pointer you give it until the null character in the string is reached. That's why you don't have a link. It expects you to have a proper string there terminated by a null. So this is for easily writing a text file. Taking input from the keyboard maybe, wherever you're taking it. And by the way, you can use fputs and fgets with stdin and stdout. Remember how fscanf has the irritating trait of stopping on the first white space character, the first blank it encounters? Now you know how to get around that. fgets. It'll read until the guy enters the return key, or it has reached the max. fputs simply takes whatever string, null terminated of course, is in this pointer and writes it to whatever file you give it. It's real simple.
Why is the type for fputs like an integer? It's int. Why isn't it like a character pointer, like fgets?
Why is this an integer?
Yeah.
I remember thinking, you don't need that thing at all there. It's just a non-negative value is all that's returned, or it returns EOF if there is an error. So you can simply compare the value returned to the thing named EOF, all caps, which is already defined for you. And that'll tell you if there's an error or not. Is equal to EOF, there is an error. The only error you typically get here is out of disk. Or, in fact, you can have metered connections, metered disk, where it only allows you to write so much. It's effectively the same thing, out of disk, which is effectively end of file. You can't write anymore. That's why it returns any error as EOF. In fact, there are other errors that can occur, like your network connection fell over and stuff. But it all returns EOF if there's an error. The third and last one we're going to get to tonight is the method called feof, which is file into file. And you simply pass it a file pointer, nothing but a file pointer. And it returns an integer. It returns 0 if not EOF, in other words, false. 0 is false is 0. What is true? Anything else. Anything non-zero. So it returns 0 if it's not EOF, otherwise it returns non-zero. So remember, this is a little backwards in thinking. EOF means end of file. If it returns non-zero, that's effectively true. True means you've reached the end of file. You use this mostly for input. Because you're just reading through the file, you need to know when you reach the end. When you do your implicit homework, you do some studying, and you see some examples, you'll see how they write the examples. And the examples are written a little backwards to most of our thinking. You'll see examples that essentially say, they will most often say, while not feof. In other words, while it's not the end of file, in other words, there's still stuff to read, keep reading. That's how it's typically written. It's just the way it is. Right? Seems a little backwards having to put the not there, but it's been this way since time immemorial. I remember thinking, when I was first learning programming back in the mid-70s, that seemed a little obtuse. So it could just be my bias of what I thought all those years ago. fgets, fputs, feof. And there's going to be more, right? But this is where we are for now. Now, a few programming notes. 3 weeks from tonight, December 7th, we'll have exam 5. Same format, review the week before, questions the night of, specific questions the night of, and then the exam. And then, right after that exam, we will review for the final exam, which will be the very next week when you have the final exam. Same format, review the week before, specific questions the night of, a limited number of specific questions the night of, and then the final exam. Now you will have noticed that you have almost reached the end of your labs and programs to be submitted. There's a reason for that. The reason is not because I'm a nice guy, because we all know I'm not, right? My grandchildren think I am, but we all know I'm not. The reason is to use the time you would have been spending on labs and programs to do additional study, to do review back, to do all of those things. So it's not free time away from the class. It's just more intense, implicit homework, studying and getting ready for exam 5, but more importantly, the final. That's why those fall off at the end, to specifically allow you time to do extra studying and playing around or writing little programs and seeing how things work.